In just 72 hours, two stars erupted with such unbelievable power that their light became visible to the naked eye. We're looking at facts, and these facts are nothing short of astonishing. They say a new star appeared in the sky visible without a telescope. Okay, rare, but possible. Yet almost immediately after that, a second one emerged. At the same time, a chain of strong earthquakes hit the same location. And as if that weren't enough, a coronal mass ejection followed. Basically, the sun fired a plasma cannon that struck an interstellar comet. Interstellar, not some rock from our asteroid belt. A true visitor from another star system. People are already calling this the 72-hour stack. Sounds almost like a cocktail name, right? I'd call it a statistical cluster with a 6 sigma anomaly, meaning the odds are so tiny that you start doubting not the event, but your entire model of the universe. Let's break this down from first principles. Point 1, 2 novae within 36 hours, both visible to the naked eye. That's an insanely low probability, almost statistical noise. Normally we'd archive such data, but this time something's clearly different. Point 2, seismic activity, Venezuela. 2 quakes above magnitude 6, only hours apart. The chance of a twin event like that in the same place is roughly 1 in 10,000. That's not background noise anymore. That's a loud, distinct signal. And then comes point 3, the cosmic target. This one's the real game changer. The sun constantly ejects mass, but for it to hit a fast, tiny interstellar object with that level of precision, that's not random, that's a planetary scale sniper shot. Multiply those probabilities together, and your calculator will throw an error. It simply can't handle numbers that small. We're way beyond normal distribution now. Anyone with a background in statistics would call this a Poisson clustering, a moment when random events group so tightly that it looks almost intentional. And that's where the main question arises. Is this a bug or a feature? Is it just a wild, unbelievable coincidence that our system happened to record, or are we witnessing the signs of a deeper, unknown law of the universe? If you multiply those probabilities together, your calculator will crash. It's just not built for numbers like that. We're venturing way beyond a normal distribution here. Any statistician would tell you this is a Poisson cluster. When random events pile up so tightly, it starts looking deliberate. And that's what leads to the big question. Is this a glitch or a feature? Could this be pure cosmic luck that our systems happen to record, or are we witnessing the fingerprint of some deeper hidden law we haven't discovered yet? Or maybe we're watching the effect of some unknown force, linking all these high-energy phenomena together, a hidden transfer of energy or information at a level we simply can't measure yet. Let's line up the timeline. This is basically a live stream of cosmic data. September 23rd, 0212 sequence start. A burst at 1935 in Centaurus. Telescopes in Chile catch it. The signal spreads across the network. September 24th, 0201. A geological trigger. A magnitude 6.2 quake in Venezuela. It was shallow, meaning the surface felt the full impact. Then on September 25th at 0350, another quake, magnitude 6.3. The system's clearly unstable. Hospitals overflow, communications collapse, a textbook cascade failure of infrastructure. September 25th, 0405, just 14 minutes later, a second astronomical signal, a flash at 9:04 in Sagittarius. Now we've got 2 gamma and X-ray sources lighting up the sky, all while our main reactor, the sun, plays its part in the background. Computer models now show a plasma front racing toward Comet 3IATLAS. The Space Weather Center is spamming updates non-stop. It's like tracking a Falcon launch, but scaled up to the entire solar system. So what do we actually have here? The 72-hour stack isn't just a coincidence, it's a stress test for our model of reality. When you see a data cluster like this, you've got to ask, is our universe model complete, or are we missing something huge? Maybe it's all noise, or maybe it's the most important signal humanity has ever received. Computer simulations reveal a plasma front racing toward Comet 3IATLAS. The Space Weather Center floods the network with constant updates. It's like following a Falcon rocket launch, but on a solar system scale. So what are we really seeing here? The 72-hour stack isn't just coincidence, it's a stress test for our perception of reality itself. When data clusters this tightly, you've got to ask, is our universe model truly complete, Or are we overlooking something fundamental? Maybe it's all background noise, or perhaps it's the most significant signal humankind has ever detected. Ignoring it would mean turning away from progress itself. We need to gather more data. We need more sensors, more eyes on the sky. We have to figure out if this is part of a greater simulation or system we still don't understand. Numbers don't lie, and they're telling us the universe is far stranger and more fascinating than we've ever imagined. That alone is enough reason to keep searching, to keep questioning, to keep observing every flicker of cosmic light. Because sometimes truth hides in the data we almost overlook. That's what makes this new star so damn inspiring. It's not just a sudden flash of brightness across the night sky, it's something far greater. A spectacular outburst on a white dwarf, a burned-out star that quietly steals hydrogen from its companion like a cosmic vampire. The process continues until those stolen sparks ignite an uncontrollable chain of thermonuclear fusion. In just a few hours, the system's brightness can increase 100,000 times, outshining billions of suns. That's exactly what happened before dawn on September 23rd, when a once-faint star in Centaurus suddenly surged into visibility. Within just a few hours, the luminosity of that stellar system can rise by as much as 100,000 times, outshining billions of suns. And that's precisely what unfolded before dawn on September 23rd, when the star at 1935 in Centaurus, once faint and almost invisible, brightened to a magnitude of 5.8. That's right on the threshold of naked eye visibility if you're watching from a dark, unpolluted sky. Events like this are so rare that even veteran astronomers may never witness one in their entire careers. Gabriela Moya, an amateur astronomer from Valparaiso, Chile, became the first person to officially confirm the outburst. She spent the entire night remotely operating telescopes, scanning the heavens for anything unusual or beyond the norm. Despite heavy clouds and occasional power cuts, she pressed on, driven by the thrill of discovery and the weight of responsibility that comes with being first. Rumors of a potential new star were already circulating in Discord chats, but Moya waited for undeniable proof before making her report. By the time her confirmation reached the Central Bureau for Astronomical Telegrams at 0212 UTC, she had barely slept for 2 straight days. Her alert triggered a wave of automatic confirmations from observatories across the southern hemisphere. Within hours, the exact coordinates of the new star were circulating through global astronomical network. What made this nova so captivating was the underlying physics. Hydrogen flowing from the companion star builds up on the white dwarf's surface layer by layer. Gravity compresses that gas until both temperature and pressure skyrocket, surpassing the 10 million degree threshold. At that moment, runaway thermonuclear fusion ignites an explosive chain reaction that hurls the star's outer shell into space at thousands of kilometers per second, lighting up the void with blinding brilliance. This massive detonation creates a shockwave so powerful it blasts through the ejected gas, heating it until it glows in visible light and emits gamma and X-rays. In the case of the star at 1935 in Centaurus, orbital detectors captured a distinct signature of hard radiation precisely as the optical brightness peaked. It's like a cosmic fingerprint of those violent shockwaves, undeniable proof that the explosion accelerated particles to nearly light speed and possibly even forged microscopic grains of cosmic dust. In less than 2 days, another white dwarf in Sagittarius followed suit, producing an equally dramatic burst. Less than 2 days later, another white dwarf in the constellation, Sagittarius, known as 994 Sagittari, did the same, reaching a peak brightness of magnitude 6.2, right on the edge of naked eye visibility. This discovery immediately sparked heated debates in the scientific community, with multiple research teams racing to claim the first official detection. Reports and data bounced between telescope logs and social media posts. High-energy satellites like Fermi and Swift caught the event almost instantly, recording a sharp and powerful spike in gamma and hard X-ray emissions that left little room for doubt about its magnitude. However, internal discussions at NASA and among the Fermi satellite team delayed any public announcement as scientists carefully checked the data for false positives. When the confirmations finally went live, preprints flooded research servers, each paper dissecting the complex shockwave physics and the particle acceleration behind these spectacular outbursts. What linked both new stars was the sheer intensity of their energetic signatures, visible not just in their light curves, but in the violent, high-energy emissions. These weren't gentle brightenings, but runaway thermonuclear reactions unfolding in binary star systems many light-years away, burning bright enough to etch their story into our night sky. It wasn't just a smooth, gentle rise in brightness. These were violent thermonuclear reactions erupting in dual star systems, unfolding light-years away, yet bright enough to inscribe their story across our night sky. The first earthquake struck shortly after sunset near the town of Monte Grande. It registered a magnitude of 6.2 at a depth of only 7.8 kilometers, shallow enough for the rupture to reach the surface, shaking buildings to their foundations and sending power lines swaying like giant swings. The local hospital, already short on medicine and supplies, scrambled to set up a triage station right outside as aftershocks began almost immediately. Head nurse Maricela Rivas, who had just finished an exhausting shift, suddenly found herself back in the middle of chaos. Calm, but commanding, she directed patients onto color-coded tarps hastily spread across the parking lot. Her voice, steady and composed, came through the hospital's WhatsApp group, updating staff about injury types and urgent needs. Volunteers from the community set up makeshift water stations and helped move critical patients away from cracked walls. 5 hours later, the Earth trembled again, this time with a magnitude of 6.3 and a deeper focus at 14 kilometers. Its epicenter almost directly beneath the same region. The sequence followed a textbook stress transfer pattern. One fault segment slips, transferring tension to the next. Seismologists from the University of Los Angeles worked through the night mapping rupture propagation along the Oka-Anon fault zone. Their analysis showed the typical aftershock decay known in geology as Omori's Law. The biggest quakes hit first, followed by smaller and more frequent tremors. Within an hour, a 5.8 aftershock struck again, forcing patients and staff to evacuate once more. Kitchen staff, volunteering as safety monitors, watched the walls for new cracks, reporting when it was safe to return inside. The immediate aftermath of this disaster showcased pure improvisation. With only 3 operating tables and unstable power, Rivas and her team prioritized children and the most critical injuries. Each time an aftershock hit, they rushed patients outside, guiding IV lines with flashlights and checking vitals by hand. Local radio stations broadcasted non-stop from the hospital, announcing supply shortages and sharing safe routes for ambulances. During those endless hours, the hospital became more than a place of healing. It turned into the nerve center for information, coordination, and the heartbeat of an entire community under pressure. Seismologists analyzing this cluster of tremors emphasized that despite the terrifying timing, the quakes still followed well-known geological laws. The Earth's crust in this part of Venezuela is constantly strained by the slow but relentless movement of the Caribbean and South American tectonic plates. When one segment slips, the stored tension redistributes, sometimes triggering a nearby rupture. Each aftershock served as a grim reminder that in a week when the universe seemed to rewrite its own rules, the ground beneath humanity still obeyed its ancient, unforgiving laws. Nature's chaos, it turns out, often follows its own brutal consistency. 5 hours later, the Earth moved again, this time with even greater force. The quake measured 6.3 in magnitude and struck deeper, about 14 kilometers below the surface, almost directly beneath the same region. The sequence fit the textbook model of stress transfer within the crust, one fault segment slipping, then passing its tension to another. Seismologists from the University of Los Angeles worked tirelessly through the night, charting rupture propagation along the Oka-Anon fault line. Their detailed analysis revealed the expected aftershock decay, commonly known in geology as Omori's Law. The strongest shocks hit first, followed by smaller, more frequent tremors. Within the next hour, another aftershock magnitude 5.8 rattled the area once again, forcing patients and medical staff to evacuate. The hospital's kitchen crew, now acting as safety volunteers, carefully inspected the walls for new cracks before signaling it was safe to re-enter. The aftermath demanded creative problem solving. With just 3 operating tables and unreliable power, Rivas and her exhausted team focused on saving children and the severely injured. Each tremor sent them rushing outside, using flashlights to guide IVs and monitor vital signs. In those dark hours, the hospital stood as both refuge and command post for an entire city in crisis. This chain of tremors perfectly matched the classic pattern of stress transfer within the Earth's crust. One fault slips, passing the pressure to the next. Seismologists from the University of Los Angeles stayed awake all night, mapping fault propagation along the Oka-Anon rift zone. Their precise analysis confirmed the expected aftershock decay known as Omori's law, where the strongest shocks strike first, followed by smaller and more frequent ones. Within the hour, another jolt magnitude, 5.8, shook the area again, forcing doctors and patients to evacuate yet another time as the hospital walls groaned under the strain. The immediate aftermath of this catastrophe demanded pure improvisation. With only 3 operating tables and flickering electricity, Rivas and her exhausted crew prioritized children and the most critical trauma cases. Each aftershock sent them hauling patients back outside, guided only by flashlights to keep IV lines steady and check vitals. Local radio stations broadcast updates nonstop, listing urgent supplies and safe ambulance routes. In those tense hours, the hospital became the community's nerve center, not just for medical care, but for life-saving coordination and vital information that kept hope alive amid the chaos. The immediate consequences of this disaster came down to human creativity and quick thinking. With only 3 operating tables and unstable electricity, Rivas and her team had to improvise, constantly focusing on children and the most severe cases. Each aftershock pushed them back outside, where they used flashlights to track IV drips and monitor vital signs. Local radio stations became a lifeline, broadcasting non-stop updates from the hospital, lists of needed supplies, emergency routes for ambulances, and messages from loved ones searching for family. The hospital had transformed into both sanctuary and communication hub for an entire community under strain. For hours on end, the hospital wasn't just a place of treatment, it was the beating heart of survival and coordination. Seismologists analyzing the cluster of quakes emphasized that, terrifying as the timing was, the events followed well-understood geological patterns. The crust beneath Venezuela sits under constant tension from the slow collision between the Caribbean and South American plates. When one section slips, the stress shifts to another, sometimes triggering nearby ruptures. Each aftershock served as a grim reminder that while the cosmos above may be rewriting its rules, Earth beneath our feet still plays by its own ancient and merciless. Seismologists studying this swarm of quakes highlighted that despite the unsettling timing, every tremor followed well-documented geological laws. The Earth's crust in this region of Venezuela is under constant strain due to the slow but relentless motion of the Caribbean and South American tectonic plates. When one fault segment slips, the accumulated tension redistributes, occasionally sparking another rupture nearby. Each aftershock was a harsh reminder that during a week when the universe seemed to rewrite its own rules, the ground beneath humanity still obeyed its ancient and merciless ones, a sobering reflection of nature's balance between order, chaos. Every aftershock carried a message, a reminder that even as stars exploded and cosmic forces collided above Earth, remained bound by its own fierce and immutable laws. The pattern of energy transfer from one segment to another was clear, predictable, and unstoppable. Each tremor felt like the planet's way of asserting control, of reminding us that chaos and order coexist on every scale. In a week when the sky told stories of impossible coincidences, the Earth below echoed back its own timeless rhythm, steady, brutal, and utterly indifferent to the wonder unfolding above. Solar maximum isn't just a trendy buzzword this year for scientists, it's a daily challenge. The number of sunspots has climbed to 165, and solar flux levels remain above 180 units. This is the environment where coronal mass ejections become routine as the sun hurls massive clouds of superheated plasma into space every few days. But what makes this cycle different is who shares the inner solar system with these storms. Comet 3IATLAS, Only the third confirmed interstellar object ever
Are these
detected
random
doesn't behave
cosmic
like a typical
flukes
comet at
or
all.
threads
Its
of a
orbit
deeper
is
design?
sharply retrograde, gliding almost along the plane of the ecliptic and moving at an incredible speed over 60 kilometers per second, far faster than any comet native to our solar system. This unique path will bring it within 0.19 astronomical units of Mars on October 3rd. That's an extremely close approach, prompting mission teams managing Mars orbiters to enter high alert, ready to seize rare opportunities for imaging and spectroscopy. Most comets we study come from the Oort cloud or Kuiper belt, distant reservoirs of our system, but Comet 3 is an outsider, a traveler from another star system entirely. This extraordinary trajectory brings the comet within just 0.19 astronomical units of Mars. On October 3rd, a pass so close that it's put Mars orbiter teams on standby for potential once-in-a-lifetime observations. Most comets we've ever studied come from the Oort cloud or the Kuiper belt distant reservoirs at the outer edge of our solar system. But Comet 3-ATLAS, or 3-ATLAS, originated in an entirely different stellar system, carrying with it ancient material that predates the birth of our own Sunday. Its arrival couldn't have been more perfectly, or perhaps disastrously timed. Passing through our solar system right at the peak of the 25th solar cycle, the comet is now exposed to the most intense and volatile solar wind conditions seen in more than 10 years. This makes it a natural plasma probe, a moving laboratory whose coma and tail reveal in real time how interstellar material reacts to violent solar weather. According to geophysicist Dr. Stefan Burns, known for his work on solar-terrestrial interactions, this encounter is a once-in-a-generation experiment. While we've seen coronal mass ejections hit comets before, never have we witnessed such an impact involving a true interstellar visitor. Passing straight through our solar system at the height of the 25th solar cycle comet, 3-ATLAS faces the most energized and unstable solar winds we've seen in more than a decade. That makes it a perfect natural probe, its coma and tail acting as instruments showing how interstellar matter reacts to extreme solar storms in real time. Dr. Stefan Burns, a geophysicist recognized for his research on Sun-Earth interactions, called this passage a once-in-a-generation experiment. He noted that while coronal ejections have struck comets from our system before, we've never had the chance to watch it happen with a visitor from beyond our own stars. Its close flyby near Mars adds another layer of intrigue. Planetary scientists are racing to coordinate observations using orbiters like TGO and MAVEN. Every dataset collected could help decode both the comet's origin and the complex plasma physics playing out at the height of the solar maximum. As Comet 3-ATLAS sweeps past Mars and heads toward its perihelion on October 29th, it's more than just a celestial curiosity. It's a rare, fast-moving target offering priceless insight for heliophysics and planetary science alike. The timing, the trajectory, and the solar activity align perfectly for discovery. The comet's close pass by Mars adds yet another layer of fascination. Planetary researchers are scrambling to synchronize observations from orbiters like TGO and MAVEN. Every piece of data gathered now could help unlock not only the comet's origins, but also the intricate plasma dynamics occurring at the peak of solar activity. As Comet 3-ATLAS races past Mars and moves toward its perihelion on October 29th, it's far more than a passing spectacle. It's a fast-moving laboratory, offering a rare chance for heliophysicists and planetary scientists to witness in real time the sun's raw power colliding with an interstellar traveler. This is the kind of scientific opportunity that won't come again anytime soon. October is shaping up to be a month worthy of the record books. There are even specific windows when skywatchers and amateur astronomers can directly participate in these historic events. The next key date is October 20th and 21st. When Comet Swan, designated as C225R2, will make its closest approach to Earth at only 0.26 astronomical units, or about 39 million kilometers. With the new moon and the Orionid meteor shower peaking at the same time, conditions couldn't be better for observation. That's roughly 39 million kilometers, and with the new moon aligning perfectly with the peak of the Orionid meteor shower, the viewing conditions couldn't be more ideal. For the best experience, head out after midnight, far from city lights, and give your eyes at least 30
For
minutes
some,
to
it is
adapt to the
simply data.
darkness. A
For
pair of
others,
binoculars
a sacred
with 7 by 50 or 10 by 50 magnification will make a big difference. A star chart or a mobile astronomy app can guide you straight to the comet's position as it drifts through the pre-dawn sky. Watching its faint, ghostly tail glide against the stars will be nothing short of mesmerizing. Binoculars with 7 by 50 or 10 by 50 magnification will help tremendously, while a star map or mobile astronomy app can pinpoint the
For
comet's
some,
exact
it's
path
just another
across
number.
the pre-dawn sky.
For others,
On October
it's the
29th
whisper
Comet,
of eternity.
3IATLAS reaches its perihelion, its closest point to the Sun during this pass, at roughly 1 astronomical unit away. It won't be visible in broad daylight, but experienced observers might catch it at twilight or sunrise. Just remember safety first. Never look anywhere near the Sun without certified ISO 2012 solar filters, and never use binoculars or telescopes unless those filters are securely attached to the front lens. Even a single brief glance without proper filtration can cause permanent and severe eye damage. When it comes to comet hunting and nova spotting, patience always pays off. Give your eyes time to adjust to the darkness and use red flashlights or dim screens to preserve your night vision. The third key date to remember is December 19th, when Comet 3IATLAS will make its closest approach to Earth about 1.8 astronomical units away. That's when it becomes most accessible for amateur imaging and visual observation, especially if its activity increases after perihelion. Although it won't be visible in bright daylight, skilled observers can try spotting it during twilight or dawn, but only with extreme caution. Never aim your eyes or equipment anywhere near the Sun without certified ISO 2012 solar filters. Even a momentary unfiltered glance can cause irreversible eye damage. In comet chasing, patience is everything. Allow your eyes to adjust to darkness and use red lights or dim screens to protect your night vision. The third key date is December 19th, when Comet 3IATLAS will come closest to Earth, about 1.8 astronomical units away, a perfect chance for amateur photographers. That's when the comet will be most accessible for citizen scientists and skywatchers alike, especially if its activity increases after perihelion. Platforms like the AAVSO International Comet Quarterly and the Comet Observation Database are already calling for public participation, estimating brightness, sketching tails, and creating frame-by-frame images. If you capture something unusual, a sudden brightening, a split in the tail, or possible fragmentation, record the exact time, location, and equipment used. Compare your notes with other observers before posting to official channels. Responsible, verified reporting helps separate real discoveries from noise and keeps the data reliable for professionals worldwide. If you happen to record something extraordinary, a burst in brightness, a bent or broken tail, or even signs of fragmentation, make sure to log the exact time, coordinates, and gear you used. Then, cross-check your findings with other observers before sharing them through official networks. Verified and detailed reports help scientists filter genuine discoveries from background noise, keeping the global data accurate and meaningful. For those organizing group viewings, especially with kids, it's essential to review safety basics before twilight. No direct sun observation, keep all optical gear pointed away from it, and use only certified filters and properly aligned laser pointers. The thrill of celestial events can tempt people to take shortcuts, but one small moment of carelessness can risk both vision and science. As October and December draw near, the night sky offers a rare and thrilling invitation. The best way to answer it is with clear minds, careful methods, and deep respect for both cosmic wonder and personal safety. When you gaze upward, remember every comet, every nova, every flash of light is a reminder that the universe still has mysteries waiting to be discovered, and we, the observers, are part of that endless story. As October and December approach, the heavens offer a rare and electrifying invitation, one best answered with clarity, precision, and respect for both the universe's beauty and our own safety. Just remember, never point your optics toward the sun. Keep all lenses protected with certified filters, and always prioritize caution over curiosity. The excitement of discovery can easily tempt people into risky shortcuts, but one careless moment can cost a lifetime of vision. The universe rewards patience. So take your time, stay safe, and let the wonder of the cosmos unfold naturally before your eyes. In just 72 hours, between September 23rd and 25th, 2025, two new stellar outbursts became visible to the naked eye. Twin earthquakes struck Venezuela with magnitudes above 6. A coronal mass ejection intersected the path of Comet 3IATLAS. The confirmed probability of such a chain of events is less than 0.1%. Each of these phenomena alone would be remarkable, but together they form a statistical anomaly so extreme it challenges our understanding of coincidence itself. It's as if the universe within a single 3-day span decided to remind us just how unpredictable and interconnected reality can truly be. Across that 72-hour window from September 23rd to the 25th of 2025, humanity witnessed two naked-eye novae twin Venezuelan earthquakes and a coronal mass ejection that collided with Comet 3IATLAS. Statistically, the odds of such alignment are below 0.1%. As new data arrives from the comet's Mars flyby, the approach of Comet Swan and the upcoming Perihelion scientists will carefully separate mere coincidence from possible correlation. The fact remains sometimes nature's rarest patterns unfold, right before our eyes, reminding us that even the universe's chaos follows rhythms we're only beginning to understand. As more observations pour in, researchers are asking the same question. Are these random cosmic flukes or threads of a deeper design? The ongoing analysis from telescopes and orbital sensors will help uncover whether these events share a hidden connection. But one fact stands unshaken. The universe occasionally reveals its most extraordinary patterns right in plain sight. For a few fleeting nights in late September space, Earth and Sun aligned in ways that defied logic and probability, giving us not just data to study, but a humbling reminder of how little we truly control. In light of these astonishing events, it's impossible not to reflect on how humanity has long interpreted cosmic signs. For thousands of years, people have looked to the skies and listened to the trembling of the earth, seeking not only natural explanations, but messages from higher powers, omens, prophecies, and divine warnings. A sudden bright star appearing in the heavens was almost always seen as an event of immense importance. The most famous example, of course, is the Star of Bethlehem, said in Christian tradition to herald the birth of Jesus Christ and guide the Magi to his cradle. For ancient astronomers and priests, the appearance of a new star often symbolized the birth of a great ruler, the dawn of a new era, or a direct act of divine intervention in human affairs. Two such stars blazing within a day and a half of each other would have been interpreted as an undeniable sign of monumental change, perhaps both good and foreboding. Comets, too, those tailed wanderers of the sky, carried heavy spiritual weight, often seen as omens of war, plague, famine, or the death of kings. To our ancestors, the heavens were never silent. They spoke in symbols. Two stars flaring within roughly a day and a half would, in the ancient world, have been seen as an unmistakable sign of massive change, both blessings and curses intertwined. Comets, those glowing travelers with fiery tails, were burdened with deep superstition and awe. Across cultures, they were believed to foretell war, disease, famine, or the fall of kings. For example, Halley's Comet, depicted on the famous Bayeux tapestry of 1066, was seen as an omen of the Norman conquest of England. To ancient eyes, such celestial spectacles were never mere coincidences. They were the handwriting of the gods. In the context of the 72-hour stack, a solar plasma burst striking an interstellar traveler like Comet 3IATLAS would have been read as a heavenly battle, divine forces clashing across the sky, their conflict echoing in the fate of humankind. The very fact that the comet arrived from another star system would have added a layer of mysticism, a messenger from distant, unseen worlds confronting the power of our own Sunday. Meanwhile, earthquakes on Earth would have been seen as manifestations of divine anger gods striking the ground to make mortals listen. The very fact that the comet hailed from another stellar system would have only deepened its mystique. A messenger from faraway, unknown realms meeting the force of our own Sunday. Earthquakes, on the other hand, were almost universally seen as expressions of divine wrath. In Greek mythology, Poseidon the Earthshaker struck the ground with his trident to summon quakes from the depths. In the Old Testament, earthquakes often accompanied the presence of God or served as punishment for sin. 2. Massive tremors, striking nearly the same place within hours, would have been read as a double warning or a divine reckoning upon humanity. The hospital turned into a place of both chaos and salvation, would have been seen as a stage where human despair met divine mercy. If the 72-hour stack had occurred not in the 21st century, but say 500 or 1,000 years ago, it wouldn't have been studied through statistics or probability theory. Instead, it would have been the centerpiece of prophecy, theology, and folklore. Chroniclers would record it as a sign of an ending age, a shifting dynasty, or even the coming of a Messiah, an event that blurred the line between heaven's will and earth's suffering. Such an event would have divided entire civilizations between those who saw divine intervention and those searching for rational earthly explanations. Theologians, prophets, and common people alike would debate whether the heavens were warning or blessing them. Scribes would immortalize the sequence in chronicles, framing it as either an omen of doom or the dawn of renewal. The sheer scale of overlapping signs, celestial fire, trembling ground, and cosmic collision would have shaken ancient belief systems to their core, becoming the centerpiece of faith, fear, and fascination for generations. Even today, in an age ruled by science and data, events like these stir something deep within us, something ancient and emotional that logic can't quiet. For many believers, such a convergence of rare, cosmic, and earthly phenomena feels like a reminder of the vast unpredictability of creation itself. It may not be taken as a direct message from above, but rather as a demonstration of power beyond human control or comprehension. Moments like this call for reflection, humility, and perhaps even prayer, reminders that no matter how advanced we become, wonder and reverence still have their place. Science explains these phenomena through physics, geology, and astronomy, while faith seeks to answer the timeless question, why? When something so statistically improbable occurs, that question becomes impossible to ignore. Perhaps there is no hidden purpose, and it's truly just cosmic chance on a grand scale. Yet, for the spiritual mind, that very improbability feels like a sign, a whisper, that the universe is not a cold machine but a living, dynamic, and perhaps conscious system, one that occasionally reminds us of its presence in the most dramatic way imaginable. For some, these events are nothing more than numbers anomalies on a statistical graph. But for others, they are whispers from eternity itself. The universe's sheer improbability becomes a kind of signal proof that existence is not just mechanical, but meaningful. A reminder that perhaps there's more to reality than formulas can explain. This ongoing dialogue between science and spirituality feels most alive when we encounter phenomena so extreme they break our models. It's in those moments when logic stumbles that wonder takes over, inviting us to look deeper into both the cosmos and ourselves. For some, it's simply data; for others, a sacred sign. The idea that the universe might be a living, dynamic, even self-aware system blurs the boundary between fact and faith. Every time we face an event that defies probability, humanity is forced to look both outward and inward to question not only what happened, but why it resonates so deeply. Perhaps these rare alignments aren't just coincidences, but the cosmos reminding us of its mysterious order, a quiet echo between science's search for patterns and spirituality's search for meaning. For some, it's just another number; for others, it's the whisper of eternity. The universe isn't merely a cold, lifeless mechanism, but a vibrant, evolving system that occasionally reveals itself in breathtaking ways. These rare intersections between scientific fact and spiritual wonder remind us that knowledge and meaning aren't opposites, they're partners in our quest to understand existence. When the cosmos performs something so improbable, it bends the limits of logic. It feels like a gentle tap on the shoulder from infinity itself, urging us to keep questioning, keep searching, and never lose our sense of awe.